Hi, in this video, we're going to bring some stuff together. We're going to talk about the IPv4 network, host, and broadcast addresses. Excuse me. So network address. Talked about this before, but the network address has all zeros in the host portion. Okay. So as we can see there, right? Yeah, let's take a look at here in binary. So looking at it in binary here, you can see we have a network address 10.1.1.0, subnet mask 255.255.255.0. And remember that subnet mask is what divides the network portion from the host portion. And the network address will always have all zeros in the host portion, all 0 bits. Okay, that's an address that can't be used by any device in the network. Okay, and this is why devices must always have a subnet mask to know what is the network portion and what is the host portion of their address. We'll see that in a moment. Yeah. All right. Broadcast address. A broadcast address is a special IPv4 address that is used to send a message to all devices on the network. And in this case, a broadcast address, well, in all cases, will have all 1 bits in the host portion. Okay, so let's take a look at what the broadcast address would be for this network. We said our network address is 10.1.1.0 with a subnet mask of 255.255.255.0. So what would the broadcast address be? Okay. Well, the network bits are going to be the same, just all 1 bits in the host portion. Okay, so what that gives us is a broadcast address of 10.1.1.255, 10.1.1.255. Okay, so in the host portion, we have all 1 bits. Okay, as opposed to the network address where we have all 0 bits. All right. And broadcast address is another address that cannot be assigned to any devices in the network. All right. So now let's take a look at host addresses. A host address is any address that in the host portion does not contain all zeros and does not contain all 1 bits. Okay, it has to have at least 1 0 bit and 1 1 bit. So if you take a look at the hosts here, all different hosts, notice again that the network portion is the same. All hosts on the network, okay, including our router interface on that network. Okay, what differs is the host portion. Okay, and as we'll see here, the host portion cannot contain all zeros or all ones. Okay, let's look at this another way. Okay, we have the network address that in the host portion has all zeros, the broadcast where the host portion has all ones. Okay, so if we look at our range of hosts that we can have on this network, the first host would be all 0 bits, leftmost 0 bits, and a 1 bit. Our last host would be all 1 bits and a 0 in the host portion. Okay? So this gives us our range of hosts. Notice that the hosts will have the same network bits as the network address. That won't change. The only thing that changes is the host portion of that address. Okay, and can't have all zeros because that's our network address. Can't have all ones because that's our broadcast. But anything in between, in this case, .1 to .254, can be assigned to a device. Okay, so let's take another look at this. Take a look at the relationship between the first host address and the network address. Notice that our first host is 1 more than the network address. Take a look at the relationship of our last host and the broadcast, and notice that it is 1 less than the broadcast. Okay, that's because Our network address is all zeros. Our first host is the very next address, all zeros and a one. Okay, goes all the way down, goes all the way through all ones and a zero because all ones is our broadcast address. Okay, so this covers all the range of addresses from all zeros to all ones and everything in between. All right, let's continue with this. So the first host address, okay, it is common that we find that the very first host address on a network is used by the router interface on that network, which is the default gateway address used by all the hosts on that network. It doesn't have to be, but it's very common. Some people use the last host address to assign to the router's interface, which would then be the default gateway address for the devices on that network. Remember this topology here? Remember that router R1 and R2, okay, has interfaces on various networks, okay? So it would actually be the default gateway address. I'll show you that in a moment. Let me bring these up. Okay, so for example, if I had a host here on the 192.168.1.0 network, let's give it a host address of 192.168.1.100, okay, /24 mask, that's the 255.255.255.0. Its default gateway address would be this address here, okay, which is also on that network, happens to be the first host address on that network. Okay, so it's important to remember that subnet masks do not always fall on a natural octet boundary. We've seen this before, right? All right, so if we take a look here at our subnet mask 255.255.240.0, okay, our ones end there and our zeros begin right there. Okay, which this in blue where the ones are, this is the network portion of our address, okay? And this would be the host portion, all right? So it causes for some, not strange, but a little more difficult to look at. Our network address is 10.1.192.0. Our first host, easy enough to figure out, is 10.1.192.1, okay? All zeros and a one. But look at the last host on that network. 207.254 is the last two octets, which is very different from the first host. And our broadcast is 207.255. Okay. So sometimes we need to convert our addresses excuse me, to binary to kind of figure out things like what is the broadcast address, what is the range of hosts, or what are the valid hosts on that network. Okay. Something else that's sometimes a misperception by some people learning networking is that network addresses do not always have to end in a zero. Okay. For example, look at this network address here. It ends in .64. That's because of our mask. Okay, so our mask is a 240 mask for this last octet. Okay, our network portion of the address, and if we look at this last octet here, okay, this belongs to the network. The first 4 bits, the last 4 bits belong to the host. Because we have a 1 in the network portion of the address, this is going to be a 64, not a 0, because the 1 where it's placed in the 64 column. Okay, so network addresses do not always have to end in 0. How about broadcast address? Do they always have to end in 255? No, same deal. Look at our broadcast address. Okay, because the network portion is, we have some zeros and ones in the network portion. The host portion is all ones, but it gives us something other than a 255. It gives us a .79. Okay, so a lot of times by converting all these things to binary, we can kind of visualize the addresses a lot easier and find out what the range of host addresses are on that network. Okay, I hope that helped bring some of this together, the network host broadcast addresses.